Hello everyone. Again welcome back to numerical studies of utilization. And today our numerical problem is an electrical train weighing 300 tons around 1% of gradient with the flowing speed time curve. This is the speed time curves. First, uniform escalation of 1.5 km for 30 seconds. Second, constant speed of 40 seconds. Third, costing for 30 seconds. And fourth, braking of 2.5 km per hour per second. Calculate the specific energy consumption if the tractive effort is 45 Newton per ton, rotational inertia effect 10%, and overall efficiency of transmission and motor is 75%. First of all, speed at the end of escalation period. V1 equal to alpha T1, so 1.5 into 30, 45 km per hour. Let the costing speed, costing between retardation be beta c. So this is the equation for tractive force, and here tractive force is 0, and put all the above value, then we can get beta is equal to 0.4863 km per hour per second, and speed at the end of costing, that is v2 equal to v1 minus beta c t3. Put the value of v1, beta c and t3, you can get 30.95 km, and braking duration t4 equal to v2 upon beta, that is 30.95 upon 2.5, that is 12.38 second, and total distance. This is the equation for total distance. Yes. So here put v1 t1, v2 t2, v1 v2 v2 t4, then you can get total distance equal to 1.0572 km, and distance travel when power is on. When power is on, then the distance travel is 40. This first and second term, we can only take this first and second term at the on, then we can get s1 equal to 0.6875 km, and this is the figure of above question. This is t1, and this from the here to here t2, and this is t3, from here to here this is t4. This is v2 from this point to this point, v2, and this is the v1. And we know a specific energy output equal to, this is the formula for a specific energy output, and again put all the value from the above, and we can get a specific energy consumption is 48.44, and a specific energy consumption equal to a specific energy output upon efficiency. So efficiency is 75% given, so 64.587 watt hour per tons kilometer.